Hello everyone, thank you for watching this video. Now in today's part of the video, we are going to look at 3G1 chapter 5 part 1 on arc length. Now before we begin to find more about arc length, let's understand the different parts and labelings and the terms, how we mention the parts of a circle. So first part, what is an arc? An arc is actually a part or a fraction of a circumference of a circle. So if you were to look at an arc, it's actually a portion, okay, a part of a circle. So usually we'll use a fraction to represent this portion, or what is this, how much is this part of a circle. So what you have down here, you can actually take a look. If you have a larger portion, this is actually called the major arc. Then the smaller portion over here, this will be called the minor arc. Okay, so this is called an arc of a circle. It forms the circumference. So before we even need to find any calculation, we must try to remember the different formulas for circumference. So circumference formula can be given as pi d or 2 pi r. Okay, so I just remember it as pi d most of the time for the class. Okay, some of you prefer 2 pi r. Please go ahead and use it. Nextly, we also need to understand what is the meaning of the word sector. Now, how can we form a sector? We form a sector when we have these two portions over here. The additional two portions over here, this one is the radius. So the radius will enclose up, will close up the make it look like a piece of a pizza or a Pac-Man. So in this case, if I have the two radius itself, the area of the circle, this is the bigger area, right? So this whole area here that looks like a Pac-Man, this is called the major sector. While the other side, the one with the radius but the smaller part of the circle, that looks like a little bit of a pizza, that is called the minor sector. Okay, so now we know that these are the names already. The arc is actually involving the circumference. Okay, one fraction of the circumference. Okay, maybe I'll write a word fraction. Okay, of a circumference. So it's actually an angle out of 360 degrees. The angle, this we call it theta. So this is actually the angle. So if I draw a radius to it, okay, I draw a radius to it, I will have an angle. So if I look at angle, that will be the minor sector. The angle out of the whole full circle, the whole full circle is actually 360 degrees. So it will be a fraction of the circumference, which is your pi d or 2 pi r. Okay, so this is how you find your arc length. Now, if that's the case, let's continue to find the formula and practice a few more questions. So how do we find arc length? Now, before we find arc length, we know that one full circle on the circumference of a circle can be given by the formula pi d, or some of you prefer 2 pi r. Okay, they give you the same value. So how do we actually calculate the arc length? For example, if I were to have in this case, to calculate the length of the minor arc, so it's talking about the minor arc, right? It's actually the smaller one. So I'll need the smaller angle, which is 80. First, I'll write this as a fraction of the whole circle. What fraction is this? This is the 80 degree, the angle that you form out of the whole full circle, 360. So I'll take this fraction, this part of the circumference, multiplied to the circumference. What's the circumference? Circumference will be pi times diameter. In this case, take note, the radius r is equals to 4. The diameter will be equals to the number 8 cm. So it'll be 2 times of it. So 8. Then we're going to work out this number. For length, we're going to keep the number as 3 significant figure. Okay, so I'll get the number 5.5850551. Then I round it off to 3 significant figure, 1, 2, 3, round up. So this one 5.59 cm. Okay, in this case, they did not write the word cm, so I just put units itself. Alright, so in general, how do we know what is the formula to find arc length? The general formula for the arc length starts with a fraction, the angle. So if I'm looking for the minor sector, it will be theta over 360 out of the whole circle, a fraction of the whole circle, times pi d or 2 pi r. This is for the minor sector. So, but then similarly, if I want to find the angle for the major sector, then I should use the larger angle over 360 times pi d. Okay, have you gotten the concept? Okay, if that's the case, let's do one example. First example, inside this example here, diagram O is the center of the circle, radius is 8 cm, angle is 135. So the angle over here is 135. They want to find the arc length of the minor sector. So the piece that has the arc length, the minor sector is this whole portion over here. This is the portion over here. But I only want this arc length, so it's looking for this arc length portion. So we're going to start with our formula. Arc length equals to a fraction. What is that fraction? 135 the degree out of 360 degree times pi d, pi diameter. What is the diameter? The radius is 8 cm. The diameter is 8 times 2, 16. Then we're going to key 135 out of 360 times pi times 16. That gives me the number 18.8495. Okay, quite a lot of numbers. To be safe, we just need to write 5. But for me, since the number at the back is 9, so I'll write a bit more. So in this case, I have 3 sig fig, 1, 2, 3. This number over here. So let's see, what am I supposed to do? This number is 4, so I'm not going to round up, I'm just going to round down. That will be 18.8 cm, 3 significant figure. For measurements of length, always round it off to 3 significant figure. Measurements of the angle, 1 decimal place. Next part, the question asks you to find the perimeter of the minor sector, the smaller piece, the minor sector. So before we begin, let me draw out the minor sector. The minor sector in this case looks like a pizza. So it has made up of 3 portions that encloses it. Firstly, we found the arc length over here already. This is 18.8495. or rather 18.8 if you want to. Okay, and we have the other 2 sides over here. This side is 8 cm. This is the radius 8 cm. So we're going to find the perimeter. We should add all of them together. So perimeter will be equals to 8 plus 8 plus 18.8495. Okay, and then we will get the number 34.8495. And we should round this off to 3 significant figure. 1, 2, 3. Round down. So 34.8 cm. 3 sig fig. Have you gotten the answer? Okay, if that's the case, it is good. We are having these basic skills already. Let's move on to the next question. Practice 1. Calculate the perimeter of a sector of a circle with the radius is 8 cm and the angle given to you is 75. So in this case, they want the perimeter. The perimeter is made up of 3 portions. This side over here and this side over here, both of them are the radius. So this number over here is also 8. Now the question is, I need to find the arc length over here. So what is this arc length that I need to find? Okay, so I should find the word arc length. So arc length equals to, remember, a fraction. What fraction is that? The angle, the small angle in this case, small sector, so small angle, so 75 out of the whole full circle, 360 times I'm looking for the perimeter, the arc length, so it will be pi times diameter. The radius is 8, the diameter will be 8 times 2, 60. Okay, and I've got the answer 10.472. Okay, I got the answer 10.472. So if now I have this portion over here is 10.472 cm, I'm going to find the perimeter of it all. I'll take the 10.472 plus the other two radius plus 8 plus 8. And that gives me the number 26.472. We round it off to 26.5 cm. Have you gotten the answer? Okay, if you know the answer, now we're going to move on to the next type of skill. So what happens now if, let's say I do not know the angle, but I am given the end result of the arc length. So I'm given the arc length in this case. In the diagram, AOB is a sector with circle center O, radius is 14, okay, but the length of the arc AB is 13.2 cm. So they gave you this length of the arc, and I need to work backwards to find the angle. So in order to work backwards to find the angle, I need to write down my formula. Remember formula, we get left hand side and right hand side, right? So I should begin with arc length equals to the angle, which is what I need to find, theta out of 360 times pi diameter. Okay, then given this formula itself that I have, remember the formula already, right? What we are going to do now is we're going to replacing the values. The arc length was given to me 13.2 cm. Okay, so I replace the arc length with the number 13.2 cm. Theta is the angle that we do not know. We're going to keep it as theta. Still 360 degrees times pi times the diameter. The radius is 14. The diameter is the number 28. Okay, so now I know this. Then what do we need to do? We are going to first get rid of the denominator over here. So I'm going to multiply, get rid of 360 degrees. I'll take 13.2 times 360 degrees. And I'm left with now, I'll get rid of denominator, right? Theta times pi times 28. Next thing that I want to get rid of, I need to get rid of pi and 28. So how am I going to do that? This operation over here is multiplication. This is multiplication, right? So if it's a multiplication, then what we are going to do, we are going to do a division. So I'll write the whole thing divided by, so it'll be divided by, I want to get rid of the pi, I want to get rid of the 28. So divided by pi and 28. Okay, for different versions of the calculator, maybe you like to put brackets. This is the numerator and that will be the denominator. Okay, and then let's try our working. 13.2 times 360 over pi times 28. And that gives me my answer. After I cancel away the theta over here, I'm left with the angle degree equals to 54.02. Okay, we're going to round off to 1 decimal. Okay, and this one will give me 54.0 degree. Have you gotten the answer? Now let's take a look at one last example for this worksheet itself. A car windscreen has a wiper that is 30 cm long. So the hand of the wiper is 30 cm long over here. The tip of the wiper actually moves an arc length of 92 cm. Okay, from point A to point B. So it swipes across and this is the arc length. Find the angle that the wiper has turned. So you need to find this corresponding angle. So what are the information that we have? We have the arc length information and the radius. So we're going to use our formula. So we'll begin with our formula. Arc length equals to the fraction, the angle. So that will be theta over 360 degree times pi times diameter. So first step, write down the formula. Second step, information that we have, we're going to replace it with the numbers. So 92 cm is my arc length. Theta I do not know. Over 360 degree times pi times diameter. The radius is 30. So the diameter will be 30 times 2. That will give me 60 cm. Okay. Now, the first thing that we do not like is, we do not like the denominator, right? The 360. So we're going to, this is divide by 360. So we're going to multiply it across. So it'll be 92 times 360 degrees equals to theta times pi times 60. Because we have no longer have the denominator already. The next part is I'm trying to get rid of the pi over and 60. This operation here is multiplication. So we do the reverse operation. We're going to do division. So we divide by pi and 60. Divide by pi and 60. Okay, so if that's the case over here, then these two will cancel away later. We are left with the theta over at this side. And we shall calculate the numbers over here. Key into your calculator. This is the numerator. This one is in the denominator. So let me press a fraction. 92 times 360 over pi. Shift times 10 to the power of x times 60. And then you get your answer. I got my answer. 175.71 lah. Okay, then I'm going to round it off. For angle, it's 1 decimal place. 1, 2, 3, 1 dp. So the number, the angle will be 175.7 degree. Have you gotten the answer? Now with that, we come to the end of this part of the lesson. I'll see you again the next time. Goodbye.